Okay, so now we are on sound energy. Okay, so it says, what is sound? It's important that you know that there has to be a vibration of some kind. Matter has to be vibrated. It says it travels as a longitudinal wave. And without a medium, there can be no sound. So there has to be a solid, a liquid, a gas, some form of matter that it can travel through. Your example is that there's no sound on the moon because there's nothing to vibrate. There is no matter to vibrate. Okay, the speed of sound is affected by three things: temperature, elasticity, and density. The higher the temperature is, the faster it moves. That's because the atoms are bouncing all over the place. They're moving really fast. Elasticity, it says the ability to return back to normal. That's what elasticity means. And the more elastic the material is, the faster it can travel sound. Okay, density, it says how closely the molecules are in the medium. That's what we're talking about. So it moves 4 times faster in solids. So it travels very quickly because they're all right up against each other. An example would be Indians putting their ear to the ground to hear buffalo from far away, way before they showed up. It says, however, to break this rule slightly, in a group of solids, the more dense it is, the harder it is going to be for the sound to make it through. It's like putting your ear up to a wooden door versus the concrete blocks that separate classrooms and school. It's going to travel through the door a lot easier. Okay, it says sound travels nearly 1,000,000 times slower than light. So we see lightning much earlier than we hear the thunder. Okay, so thunder is the sound that lightning makes. You do not need to know how to calculate all of this. You just need to know up to thunder. So you can just stop like right there. Okay. Frequency is how often a wave passes a certain point. If we're looking at this picture, we would count 1, 2, 3, 4, 5, 6 hertz. We would say that this represents 1 second. So 6 waves have come by in just 1 second. So this one has a frequency of 6 hertz, and this one only has a frequency of 2. Okay, and pitch. Think about people who have really low pitch voice, like Chef on South Park, or somebody with a really high pitch voice like Mariah Carey can hit some really high notes. The higher the frequency, the higher the pitch. So in this picture right here, this top one might be a girl's voice and the bottom one might be a man's voice. Okay, intensity in regular words means loudness. The more intense it is, the louder it is. So if we had 2 waves and one only went this high up and the other one went all the way up like this, then we would say that the second wave is much more loud or much more intense. And it's measured in decibels. Okay, sounds over 120 decibels hurt the ears, and also they can be too low and hurt the ear too, so anything less than 85 hertz. Okay, here's a picture of a shock wave breaking the sound barrier. Okay, the Doppler effect. This is when sound changes the way it's traveling based on if it's ahead of you or moving away from you. So if it's moving toward you or away, it's going to change. An example would be if you're hearing a police officer, a siren of some kind. It's really high pitched, and then the second it passes you, it's instantly lower. Okay, so an example would be to listen to this one. So let's try it one more time. Listen, you'll hear the moment it moves past you. Right there. Okay. We'll watch that in class. Okay, acoustics is the science of sound. That's what you should write. Scientists always try to make perfect concert halls, auditoriums, amphitheaters, theaters, trying to find a way to make the sound its best. Okay, we don't want to hear echoes. You don't want to have areas where you can't hear anything, and this does happen. Timbre is what we call an instrument's ability to have its own sound quality. If I were to play the piano, guitar, drum, harp, and your eyes were closed, you could probably tell me exactly which instrument each one is based on their timbre. Okay, music is the pleasing quality. It has a definite pitch, a repeated timing called rhythm, and we would say noise has none of those things. This is usually a matter of opinion. That screamo music that some people like, to me, sounds like noise, and maybe to you it sounds like music. Okay, but when we look at it, you can see like the rhythm. We can see that it goes up pretty much the same every time we're here. It's all random and scattered, and we would say that that's noise. Sonar is a device used to locate large schools of fish. Um, it sends out a sound vibration, and however long it takes for it to come back, they can tell how far away the object is, or objects if it were a school of fish. Okay, echolocation is the same idea. Bats use this to find their way around. They send out a noise, tells them how far away an object is. Dolphins could use this when the water's really murky or unclear and they can't really see their way around. Humans, we use this kind of technology when we do ultrasounds to see babies. Okay, this is the old ultrasounds. Many of you probably have a picture just like this. That is you. And now you can really see the baby. Ultrasound has come a long way. Okay, echo versus reverberation. An echo sends back the sound exactly the way it was. It has to hit something flat and come back. Reverberation is going to send it back several times, and it's not going to sound exactly the same. Okay, hearing. You do have to know what takes place. Don't write this entire thing, just shorten it. So hearing begins when the sound wave goes in through your outer ear, hits the eardrum. Okay, from there it hits three little bones. The first one is the hammer, then the anvil, and then the stirrup. From there it goes into a cochlea, which is shaped kind of like a snail shell like this. And in there it gets amplified and sends it to the brain, and then the brain tells you what you're hearing, and it happens that fast. Okay, so when we look in here, here's your eardrum, you have your little bones, see there's the stirrup, and then it travels into the cochlea, sends it in here as an electrical impulse to the brain. Okay, that's all of your notes. Be ready to show them to me next class, and I will see you on Monday.